35. Simplify the expression. Use positive exponents only. The answers are going to always want positive exponents, even though there's negative ones in the problem. So we have a to the negative 2 power, b to the 5th power. That's enclosed in parentheses, and that whole parentheses is to the negative 5th power. So everything in the parentheses is to the negative 5th power. So what we can do is we can just use the rule where we can multiply these exponents, because the negative 5 is on the outside of the parentheses, so that everything in the parentheses goes to that power. So we'll try that first this time. Okay, so negative 5 times a negative 2 would be a positive 10. So we've got a to the 10, and negative 5 times 5 would be a negative 25, b to the negative 25. But we want all positive exponents. So that means that b to the negative 25 is actually going to be a to the 10 times 1 over b to the 25th. So our answer would be a to the 10 over b to the 25th. We can factor this whole thing out. So a to the negative 2, b to the 5th would be the same as 1 over a to the negative 2, b to the 5th to the 5th. So if we factor that out, we've got 1 over a negative 2, b to the 5th, a negative 2, b to the 5th, a negative 2, b to the 5th, a negative 2, b to the 5th. So we can squeeze another one in here. A negative 2, b to the 5th. Okay, so 1, 2, 3, 4, 5. Okay, good. All right, so now let's look at our a's. We've got 1, 2, 3, 4, 5 a's to the negative 2. So 5 times the negative 2 is a negative 10. So let's just rewrite it. I'll rewrite it over here. 1 over a to the negative 10. And then we have b to the 5th, 1, 2, 3, 4, 5 times. So it would be b to the 25th. Okay, so that 1 over a to the negative 10, we can't keep it that way because we want positive exponents. So just like we took something with a negative exponent that was on top of fraction bar and put it below as a positive, we can go the opposite way. We can take that negative 10 and put it on the top and make it positive. So we'll go a to the 10 over b to the 25th, which is the same answer we got before. Okay, number 36. Write the number in standard notation. The number is 1.14, or 1 in 1400ths times 10 to the negative 4. All right, to explain this, I'm going to give a brief rundown of scientific notation, because this is in scientific notation. Scientific notation is all about powers of 10. So, for instance, just 10 standing like that is 10 to the first power, which equals 10. And 10 to the second power, that of course means 10 times 10, or 100. So you can see where we're going with this. We've got 10 to the third power equals 10 times 10 times 10, or 1,000. So 10 to the fourth power equals, that was 1,000, 10,000. Notice the number of zeros and the exponent. The exponent here is 1, so it's 1 with 1 0. Exponent here is 2, So if you wrote it out in standard notation, well, it's all standard notation here, would be 1 with 2 zeros, or 100. 3, 3 zeros, 4, 4 zeros. So if I had 10 to the 60th power, it would be equal to 1, and then I'd have to have 60 zeros, right? So starting out again, 10 to the 1 power is 10. But what about 10 to the negative 1 power? Well, that's just 1 over 10. Just like our rules for exponents, 10 to the negative 1 would be 1 over 10. So 10 to the negative 2 would be 1 over 100. 10 to the negative 3 would be 1 over 1,000. But if we wrote these in decimals, this would be 0.1, this would be 0.01, this would be 0.001, and so on. So that that exponent, 10 to the, say, negative 60 power, would equal 1 over 1 with 60 zeros, right? But the decimal would be a decimal with 60 decimal places. It would have, so it wouldn't be quite exactly the same. We'd have 60 decimal places. We'd have actually 59 zeros and then a 1 on the end. Notice here, there's the negative 3, 10 to the negative 3 has 3 decimal places. It doesn't have 3 zeros in it. It has 2 zeros and a 1. Second, 2 decimal places. And the negative 1, 1 decimal place. All this information is used when we're working with scientific notation. So 1.4 times 10 to the negative 4 would be the same as 1.14 times 0.0001. You see, there's 4 decimal places there. And if we multiplied that out, we would get 114, and then we would count our decimal places. We have 1, 2, 3, 4, 5, 6 decimal places, right? So we'll start here. 1, 2, 3, 4, 5, 6. And that would be the number written in standard notation. However, let's just do a shortcut for all this. Let's take that 1.14 times 10 to the negative 4th power. Okay, and we'll say, all right, we're going to change it into standard notation. So we have 1.14, and I'm just going to add 4 more decimal places to get rid of this 4. So 1, 2, 3, 4. And there's our number. Notice it's the same thing. So you don't have to go to all that trouble. You just, when it's a negative 10 to the negative power, you just take away the 10 to the negative power, and then you add that many decimal places. In this case it was 4, so we add 4 more decimal places. We start at the decimal point and we do these swoops and put a 0 in each empty swoop. When we have a number in standard notation, like 580,000, we just go the other direction with it. So we take 580,000, and we have to bring it down to a number that's between 1 and like 9.9999999. It can't get as big as 10, but it's got to be less than 10 and 1 or greater. So you find the decimal point on the number itself, which is, this one is right here. And we're going to take away decimal places until we have a number between 1 and 10. 1, 2, 3, 4, 5. So this is where our new decimal place will be. So it will be 5.8 times 10. And guess how many? Well, we have 1, 2, 3, 4, 5. We took away 5 decimal places, so we'll put a 5 here to record it. So 5.8 times 10 to the 5th power. It's just a shorthand. Okay, number 38. Find the value of the polynomial at the given replacement value. We have 3x squared plus 4x minus 3 when x equals a negative 2. So this is just a substitute. We just substituted that negative 2 in. Stick the negative 2 in for all the x's, and then calculate what it is. So it's actually a pretty easy problem. We've got 3, then we have x squared, so we'll put the negative 2 in there. That's still squared, plus 4 times negative 2 minus 3. So now all we do is use our order of operations. So negative 2 to the 2nd power is 4. So we've got 3 times 4 plus 4 times negative 2 minus 3. 3 times 4 is 12 plus negative 8 minus 3. Okay, so let's add our negative numbers together. This is a plus of a negative 3, right? So we have 12 minus 11, which is 1. Answer is 1. Number 39. All right, we have a subtraction problem of a polynomial. So now this is where people get screwed up. They've got used to adding exponents when they multiply variables with exponents and subtracting them when they divide them. But here we're subtracting. We're not doing any multiplying or dividing. So we just can add like terms. It's just an order of operations problem where we're combining like terms. So don't forget that. Otherwise you're going to cause yourself untold grief. All right, so we've got 2x squared plus 7, and then that is minus this thing, a negative 4x squared plus 7. So easiest way to do this one is we're going to just change the signs to make this a distribution. So this is the same as a negative 1 times negative 4x squared and a positive 7. Just because we've been doing different things doesn't mean we stop doing the same things we've been doing all along that were correct. They were correct before, they're still correct. Okay, so we'll just rewrite this one. We have 2x squared plus 7, and here we're going to distribute that negative 1. So we get a positive plus a positive 4x squared and a minus 7. Okay, so now we can remove our parentheses. And so we have 2x squared plus 7 plus 4x squared minus 7. Starting to look familiar, right? Okay, so we'll combine these two. 2x squared plus 4x squared is 6x squared. Positive 7 plus a negative 7 is 0. So our answer is 6x squared. Again, this is an addition problem. And we can do this a few different ways. We can do it just the same way we did the last problem, except there's no distribution going on here. We just add like terms. So why don't we do that first? So we have, I'm just going to take away the parentheses now. We have 3x squared minus 7x plus 4 plus 5x squared plus 4x plus 1. We're just adding like terms. So we can add these two together. 3x squared plus 5x squared gives us 8x squared. Then let's see. All right, here's two terms that have x just to the 1 power, or just x. So we'll add those together. When we add positive and negative numbers, we subtract them, and we keep the sign of the larger number. So negative 7 minus 4, 7 minus 4 is 3, so we have a negative 3x. Then our last two to combine will be the constants, the numbers 4 and 1. So it's plus 5. So our answer is 8x squared minus 3x plus 5. Notice we didn't add any exponents there. The exponents stay the same. We're not multiplying or dividing. Okay, the other way to do this is to put them on top of each other. 3x squared minus 7x plus 4. Let's just make a divided line here. I'll get them mixed up. 5x squared plus 4x plus 1. We're going to add them all together just like that. So we get 8x squared minus 3x plus 5. Notice we get the same number as this one. Okay, number 41. We're closing in on the end. This 2x to the 4th power times x squared plus 2x minus 6 is just a distribution problem. But it assumes that you know how to deal with exponents. So we're going to take this 2x to the 4th power and multiply it times this one, that one, and that one. So 2x to the 4th times x squared gives us 4, 5, 6, 6 x's. 2x to the 6th. 2x to the 4th times 2x gives us 5 x's, right? X to the 4th, and then there's x to the 1, understood, right? So, and we multiply the numbers times the numbers. So 2 times 2 is 4, and x to the 4th times x is x to the 5th. And then we have 2x to the 4th times the negative 6. And we multiply the number times the number. We don't have a variable there. So 2 times the negative 6 is negative 12. And then we keep our x to the 4th. Couldn't be easier, right? Now here we have the multiplication, number 42, of two binomials. Binomial is just two numbers, two terms, right? Y minus 7 times 5y minus 3. This is like distribution. Only when you have in your first thing you're multiplying, you've got more than one thing, you've got to multiply each one of those things times each one in the second one. Normally we just have one thing, right? So in this case we have two. So we'll take, and we'll go, we have y minus 7 times 5y minus 3. Okay, so the first thing is we'll take the y. This is also called the FOIL method, but I don't like to call it that. Y times 5y is 5y squared. There's two y's to the first power, so y times y is y squared. And there's just y is 1y, so 5 times 1 is 5. Okay, so now we're going to do the y times the negative 3. So y times the negative 3 is negative 3y. Okay, so now we're going to take our second one, multiply the negative 7 times 5y, and we get a negative 35y. So now I'm writing in red. And then we take that negative 7 and we multiply it times the last term. Negative 7 times the negative 3 is positive 21. Positive 21. Now all we have to do is combine like terms. The only like terms we have are these two. All right, so we know how to combine those. We have negative 3y plus a negative 35y is a negative 38y. So our answer is 5y squared plus, well, let's get rid of that plus, 5y squared minus 38y plus 21. Number 43, x plus 10 whole thing squared. Now if you know the pattern here of a binomial squared, you can just write it right out. But otherwise, if you don't know the pattern, do it this way. Whoops. This way. It's this whole, everything in the parentheses is squared. So x plus 10 times x plus 10. Alright, and then we just take our first number, multiply it times both of them. So that gives us x squared plus 10x. Alright. Let me erase these to avoid confusion. And then we take our second number and do the same thing. Okay, so that's, oops, let's make that black. That's 10x plus 100. So we combine like terms, and we only have two like terms, and we get x squared plus 20x plus 100. And you see when you take a binomial to the second power, you square the first term, you square the last term, and then you have the first term times the last term doubled. But you don't have to remember that. You just, it's easy enough to multiply the whole thing out. Number 44, we have 4x minus 2/3 times 4x plus 2/3. This becomes the difference of two squares. If you don't notice that, you can just still do what we just did in the previous problem. You can take 4x times 4x, and then you go 4x times 2/3. Then you take the second number and multiply by both of them. We'll start with the first one. 4x times 4x is 16x squared. 4x times 2/3 is a positive 8/3 x. Okay. Now we'll take the second number, negative 2/3, and we'll multiply it times the two other numbers. So it's a negative 2/3 times 4x, which gives us a negative 8/3 x, and a negative 2/3 times a positive 2/3 will give us a negative 4/9. Now notice something. These two middle terms, the two like terms, they cancel each other out. One's positive, one's negative. That's why this becomes the difference of two squares. 16x squared minus 4/9. 16x squared is 4x squared, and 4/9 is 2/3 squared. And see, so when you have the two numbers that are multiplied times each other, but one section, the second one is negative, and one they're both positive, this is what you get. But you don't have to recognize that. You can just multiply the first number times both, and then the second number times both, and then add them together. Number 45, our last problem. Woohoo! Guess we should have some fireworks or something here. Anyhow, what we have is we have a polynomial divided by one term. So you can have a polynomial divided by anything, but here we just have one term, and it may look really scary, but it's actually quite simple. It's sort of You could say it's like distribution in reverse. We are going to divide this 2xy into each of these. Just like we would if we were distributing it across them, we would multiply it times each of them. Here we're going to divide it into each one of them. We're going to do it one at a time. Okay, so first we have 2xy into 2x squared y. If you need to, bring it over on the side and go like this. 2x squared y divided by 2xy. That might be easier. See, so you can see that the 2's cancel out. The x cancels out one of those x's. So we still have an x though. Okay, and then the y's cancel out. So all you have there is x. So we'll put that one for the first one, x. Okay, so now we'll do the next one. We'll go 4x squared y squared divided by 2xy. Again, the 2 goes into the 4 2 times. The x goes into the x 1 time, so I only leaves one x. I think I'll just cross out the 2. The y goes into the y 1 time. So there's what we have left. We've got 2 times xy left. So this is plus 2xy. Now I'll do the last one. It's the negative 8xy squared divided by 2xy also. So 2 goes into that 8 4 times, so that's the negative 4. X cancels out the x. The y, so we have 2 y's there, y times y. We'll just cross out that. And so we have y. So that equals a negative 4y. Negative 4y. That is our answer. Let's do that again in a little bit different way. Now you know we're gonna keep this 2xy divides into each one of those, each one. And when it's done, then it's gone. But not till it's done. Okay, so now I'll do the 2xy into the first one. 2 into 2 is 1. X into x squared is x. Y, whoops, I didn't mean to do that. Y into y is 1. So it basically cancels that out. So we have 1x, or x. I can erase that 1 now. Okay, the next one. 2 into 4 goes 2 times. The x into x squared goes x number of times. The y into y squared goes y. See, so we have x plus 2xy so far. Now the 2 goes into 8, or negative 8, negative 4 times. The x goes into the x once, so don't even need to put that up there. They both cancel out, and the y goes into y squared y times. So notice, now this is gone. Okay, so notice we get the same answer. We get x plus 2xy minus 4y.